So good morning everybody. Welcome to the COREALIS second webinar for intra-terminal operations state of the art. Before proceeding, I would like to mention that this webinar is being recorded, so if you have any objection with this, please feel free to disconnect. Okay, those of you that you choose to attend, please mute your microphones in order to avoid any background noises and keep your questions for the QA session at the end of this webinar. For those of you that do not know me, my name is John Kanelopoulos and I'm working as a senior researcher and project manager at the Institute of Communication and Computer Systems of the National Technical University of Athens. Before passing the word to our experts, I would like to introduce you into the concept of the COREALIS project. So COREALIS proposes a strategic innovative framework supported by disruptive technologies, including Internet of Things, data analytics, next generation traffic management, and emerging 5G networks for cargo ports to handle upcoming and future traffic, efficiency, and environmental challenges. The proposed beyond state-of-the-art innovations that will be presented during this webinar target to increase the efficiency and optimize land use while being financially viable, respecting circular economy principles, and being of service to the urban environment. So the COREALIS innovations will be implemented and tested in real operating conditions with real data coming from different data sources and from different stakeholders in 5 living labs. Among these labs are 3 of the biggest terminal ports in Europe, the Antwerp port, the Valencia port, and the Piraeus port, while also we have some mid-sized terminals in our consortium, the Livorno port and the Haminakotka port. We are going to start our session of presentations with Mr. Ville Hinka, who works as a senior scientist and research project manager in VTT Technical Research Center of Finland. His research area is in supply chain management, and his richest interests are in adoption of digital technologies in supply network and reverse logistics solutions. He will introduce us to the maritime ports, sustainability requirements, and their focus in this area. So, Ville, are you ready with your presentation?
Yes, John, thank you. I'm ready.
Okay, let me make you a presenter then.
Okay, thank you. Okay, my name is Ville Hinka. I'm going to present, as said already, about sustainability requirements from ports and port sustainability focus. Okay. Okay, first, I would like to introduce some aims and directives of European Union related to port and maritime sector. The primary aim of European Union is to mitigate the environmental impact of transport. The long-term objective is zero waste, zero emission in maritime transport. Comparing to many other transport modes, waterborne transport has less negative environmental impact per ton kilometer and therefore the Commission aims to increase the share of waterborne transportation, especially in short distance shipping. One aim is to minimize dependence on oil, and therefore member states should provide an appropriate number of LNG refueling points for maritime and inland waterway transport. And for waste management, all ships that stop over in European ports are obliged to deliver in port their waste on board of ships. And to motivate vessels to do that, ports should also set their waste tariffs based on the vessel size and not the actual amount of the waste. Okay. It seems that the slide doesn't change. for some reason.
Would you like to change back to the standard view? Okay, that's it then.
No. Okay, then I would like to introduce the Espoo EcoBot survey, which was made in last year. They made it every year, and currently the main environmental priorities of the ports are based on that survey. First, air quality; second, energy consumption; and third, noise. The other environmental priorities are relationship with the community, ship waste, port development, climate change, water quality, dredging operations, and garbage, port waste. Then we made in the COREALIS project, we made a study about what the ports view the sustainability issues, and we reviewed the public English websites of the 10 biggest container ports in Europe. And in the left-hand side, there is in the left-hand column, there is a list of these 10 biggest ports, and we used almost the same indicators and as was in the Espoo EcoBot survey. And based on this, our findings, we made the following matrix, which you can see on your screen. And based on that matrix, it can be seen that what kind of issues the ports consider as important. So important that they have mentioned it in their website, public website. And as a conclusion of this study, it seems that the majority of the ports are aiming to decrease the harmful environmental impact of port operations in various ways. And ports also consider their position as a part of surrounding neighborhoods and supply chain. For example, by acknowledging the importance of railway connections for cargo, and by considering the sustainability of commuting of people working and visiting in port area. I'm sorry to interrupt, that if someone has microphone on, because there is an echo. And then the web pages of the ports contains various information about sustainability intention of ports. For example, 2 ports do not have any material about their relationship to sustainability intention in English. And in addition, many other ports doesn't even mention environmental actions that are obliged by law. We don't want to believe that these ports that do not mention about these issues, that they don't care about sustainability. But for some reasons, these ports do not have made the choices that they don't tell about this. Then finally, some general conclusions about our study. That we found, for example, one interesting study funded by European Maritime Safety Agency a few years ago. And based on the study, different European ports have different systems even inside one country. For example, related to waste management, in some ports, charges increase if the amount of waste is bigger, which is not according to directive. But there are also some ports which imposes financial sanctions for those ships not delivering any waste. And one important thing is that the importance of sustainable supply chain management has increased during the past few years. And so far, the production-related matters, for example, poor working conditions, pollution, and so on, has gained the biggest public attention. And based on that negative public attention, some companies have been forced to change their sourcing. However, the following logical step would be that the transport route-related choices, for example, which logistics hubs or locations are selected, they gain similar attention in the future. And if that happens, then it's not irrelevant for the ports how they think about the sustainability questions. If they get bad reputation and companies start to avoid certain ports because of the public pressure that this bad reputation has. So thank you for your attention, and John, you can continue for the next presentation.
Thank you very much, Ville. We are now going to proceed with Ms. Cihet Chiari. Ms. Cihet Chiari is a research scientist at NECLABS Europe. Her focus is on data analytics and machine learning techniques for real-world applications such as intelligent transportation systems and retail. Cihet is a valuable member of the technical team of our project, and she will introduce us in asset management and port strategies. Cihet, let me make you a presenter in order to proceed.
Yes, thank you, John. So thank you, John, for the introduction. I will be mainly talking about the software and infrastructure possibilities that are used in ports for asset management and port strategies. So this work has been done when we wrote the deliverable, and we tried to cover as much as possible. Here I will cite some examples to give you an idea. So in general, the software and infrastructure side is focused on these three lines. So first we have the asset management, second the terminal operation management, and it's also relevant to talk about the planning of container terminal layout. So when we talk about assets in general, these are either infrastructure, property, or utility management and maintenance. In general, some ports separate and use different systems for different functions. For instance, asset management, terminal operation, finance, procurement, inventory, human resources, payroll, and management of processes and workforce. The main solutions are these four ones. So first we have general AMS. So this is an asset management system which can be used to monitor and maintain items of value, not only tangible ones but also intangible ones. So tangible assets can be cranes or quay walls, and intangible ones can be intellectual property or financial assets. An EAM is an enterprise asset management, and it gives real-time visibility into assets usage, manages assets life cycle and energy consumption. So it's more of asset management in a timely fashion. It's not. It always evolves. It's dynamic. It's not. It's different to the AMS in this aspect. An ERP is also a popular solution, and it's an enterprise resource planning system which can include either an EAM or an AMS. A GIS, it's a geographic information system, and there are many GIS-based asset management systems which rely a lot on the geospatial and temporal data about the port. So here in this table we cite some examples of the systems that we mentioned before. In the category we can see which of the systems we mentioned before is relevant, and the examples are, for instance, Ascetic, ESRI, Envacon, SAP, or IBM. This is of course a non-exhaustive list. It's just to give an idea. As for terminal operations management, it means that this management is about either the planning activities, control and optimization activities, or decision-making processes. So a TOS is generally used in order to have an overview of the operations, and this can help in meeting faster and smarter decisions. And the ultimate goal is to have a higher efficiency. Similarly, as before, we list here some examples of popular solutions that are on the market. For instance, there's ABB, Accenture, Kalmar, Navis, and sometimes we can have different TOSs that focus on specific functions. So for example, here ABB focuses on container and bulk cargo handling, whereas Navis seems more focused on the efficiency, so on the optimization of these functions. Okay, a part of the terminal operations which are particularly interesting for our work in COREALIS are maintenance tasks, since we are working on a predictor to deliver predictive maintenance solution. So in general, maintenance is related to the function and availability of port operations, and it can be included in the EAM or ERP or CMMS. CMMS is specifically for maintenance. In general, there are 4 strategies. So there's emergency maintenance, which is also called run to failure, or corrective maintenance, because the strategy is to fix when something breaks. And there's preventive maintenance, which can be performed in a routine way. It's according to the summary here, it's a predetermined schedule. Predictive maintenance is when we look at the condition of the equipment and historical data in order to predict whether or not maintenance is required. And there's RCM, which is reliability-centered maintenance. So this can rely on some reliability studies from a physical point of view and infer decisions about maintenance. Okay, third, there's the software for plane container terminal layout. In this case, there are simulators that are adopted, such as ChessCon and Controls. There are many more other solutions like Constim or Cybercube. Excuse me, or general discrete event simulators such as Arena and Analogic. However, planning and simulation can be performed either separately or jointly. So this is a major solution, since it relies, it has to deliver solutions for the port in order to better utilize the space that it has. So a recent project in Hamburg has worked on trying to have planning and simulation at the same time. And lastly, I'm going to talk about some examples in COREALIS of the solutions and software infrastructure that is used. So as John mentioned before, COREALIS technologies are to be implemented in 5 living labs in 5 prominent ports in Europe. And in these ports, there are different solutions that are related to asset management. Some examples are the predictive maintenance tool that I mentioned before. It relies on data that are drawn from the EIM, the TOS, as well as the telemetry system for the trucks in order to predict when maintenance is required. In Valencia, a truck appointment system is under development, and this relies on fleet management that delivers information about the trucks, namely their position and utilization. So the point is to have appointments for the trucks in order to facilitate their operation, and part of this component is to have prediction of the position of the trucks. That's why we need the data from the fleet management system. There are also AutoGate systems that interact with the truck appointment system, and just-in-time rail and platform sharing systems. So this is just a brief overview. Thank you very much, and I look forward to your questions later on.
Thank you very much for your presentation, Jihad. We are now going on to proceed with the presentation from 2 of our colleagues, Mr. Gianno Pinola and Alexander Tardo. Mr. Gianno Pinola works as a senior scientist in the connectivity research area at VTT Technical Research Center of Finland, and his background is in telecommunications, where he has worked on deployment, management and testing of various different technologies. He is currently focusing on 5G and beyond networks, with special interest on the visualization and programmability of the radio access network infrastructure. Mr. Alexandre Tardo is a communication engineer. It's part of the research group of the CNITAS system platform analyst, and he's working at several aspects related to digital platforms currently used in the port of Livorno. They will both introduce us in the cutting edge and disruptive technologies for smart terminal operations. So let me make you a presenter, Jarno, in order to start with the presentation.
Lead you into the cutting edge and disruptive technologies part of the webinar, and start the presentation with a few ICT and IT megatrends that are most relevant for industrial operations, such as smart ports, transport and logistics at the moment. So first in the summary list that we have in the deliverable is IoT. That is already used and have been used in various use cases, also in ports for years already. But the problem with the IoT solution so far has been that it's missing a common connectivity platform. The interoperability of these systems that have been deployed in ports is basically non-existent, and these different radios and data management platforms are not talking to each other very efficiently. This brings me to the next current trend, that is the upcoming 5G network deployments. Commercial deployments have been started this year, and during the coming years the availability of 5G networks will be better. So this infrastructure that is built by the commercial operators is a viable solution for the common connectivity platform, also for the IoT use cases. So 5G networks will in the future offer a massive scale platform for the connectivity part with devices and functionalities, also for the business and industrial use cases, not only for the humans and the mobile broadband as in the past generations of mobile networks. Then machine learning, something that is popping up in different applications nowadays quite a lot. Also in industrial use cases, machine learning is already utilized in several applications. For example, subsystems related to automated machinery or warehouse logistics and things like that. Machine learning is already doing optimization for the operations. But when we are able to combine machine learning AI with IoT in real operational environments where IoT provides the information that can be transferred and shared via 5G networks, and then processed and interpreted by the machine learning algorithms, we will have a really potential, let's say, system of systems for also for smart port operations in a larger scale of automation. So this combination of IoT, 5G, and machine learning and AI enables the interoperability of the systems, both on the communication protocol and data semantics level in the future, and this in turn can facilitate better deployment of logistic optimization and optimization of logistic operations, such as physical internet and things like that. More as 5G is is this kind of a glue between the other two, IoT and machine learning. A little bit more about 5G. So 5G, when compared to 4G and even other mobile communication technology generations, is more flexible, provides better performance for the industrial use cases. 4G networks were originally designed for mobile broadband use cases, so they are not very adaptive when it comes to use cases that require machine-to-machine communications, for example. 5G, on the other hand, already from the get-go enables these kind of, let's say, better tailored sub-networks or logical networks for different services that are running on top of the network. So we are able to better adapt our communication infrastructure for services that require, on the other hand, for example, video streaming, and on the other hand, machine-to-machine communications. And why 5G is able to do that is because it's cloud-based, unlike the previous generations, which were hardware-based, monolithic integrated infrastructures. 5G will be cloud-based, programmable, supporting virtualization and these slicing techniques, which are also visualized in the picture on the slide. So slicing in practice enables the creation of these, let's say, logical isolated private networks on top of the same physical infrastructure. So we can run private networks for different industrial services on top of commercial ones, without the risk of sharing private information with the commercial or customers. We can pick and choose based on our needs in the service that we want to run in the network. We can pick and choose the features and the functionalities in the network we would like to use. 5G also provides this kind of a local cloud environment for edge computing. So in the port operations, this kind of edge computing can be used for the processing of critical, time-critical or confidential information or data locally, which also facilitates the utilization of AI and machine learning algorithms in live environments, and it also enhances the general security of the network that is used for these port applications. So in addition to the general authentication privacy issues that usually have been a concern in mobile networks, this is more easily handled in 5G and in networks, and with the isolation of these logical network slides. And this is in a sense a clear step change to the current situation where ports are deploying a lot of parallel standalone communication systems for different services. 5G can bring the communication under one system, which enables then better sharing of information between between systems in the area. So that's all I had for the introduction of the topic, and Alexander will continue with more details on the 5G and its use cases in port infrastructure. So thank you from my side, and Alexander will continue.
Thank you, Jarno. Let me make Alexander a presenter.
Alexander Tardev from CNIT. Thank you, Jarno, for this short overview regarding the cutting-edge technologies. So the main aim of this presentation is to provide you a general overview related to the 5G technology in itself, and then maybe to focus on specific aspects of this technology if applied to the port community context. So basically, this is the current state of the art, defining the whole new standard for 5G is not an easy task. That's why 3GPP has split the 5G standard into 2 releases. So basically, there's release 15, which corresponds to so-called new radio phase 1, and the release 16, which corresponds to the new radio phase 2. And while the release 15 has been already finalized in June of the previous year, with the specifications related both to the non-standalone and standalone configurations of this technology, the release 16 is still under development. So the main content of this release will focus on, on a wide range of new features, such as MIMO and informant enhancements, user equipment improvements, network slicing, vehicle-to-everything communications, and so on, in order to provide, differentiated quality of services, and in this specific context. So basically, of course, this is done in order to meet the ITU and MT 2020 technical requirements. And basically, what kind of requirements are we talking about? We are talking about aspects such as connection density, energy efficiency, mobility, or the interruption time during the mobility, general bandwidth, spectral efficiency, and higher data rates along the control plane. So, as already mentioned, I'm not able to scroll the slides. Okay. As already mentioned, the 5G requirements have been broadly defined within the release 15 for different types of communications. Some examples, or basic examples, are represented, shown in the figure. So we are talking about enhanced mobile broadband, defined on high data rates, higher traffic or connection density, higher user mobility, and so on. Then we are talking about critical, ultra-reliable, and low-latency communications, defined on basically on the radio interface, and the massive machine-type communications, or if you want, a massive Internet of Things, that basically is the same, defined on very high traffic densities of devices in itself. So in reality, there is also the aspect related to flexible network operations, as mentioned before, which covers aspects such as network slicing, scalability issues, different types of mobility, some security aspects in general, or let me say, efficient content delivery, and in general interworking. So this variety of requirements enables different sectors of industry that we could define as verticals. And for example, for instance, we could talk about automotive and transport services, logistics, and discrete automation that is part of automotive field, public safety, health and wellness, smart cities if you want, media and in general entertainment. So this allows to enable several use cases, as you can see in this picture. And in this slide, I would like to show you some performance aspects. The question is, why do we need 5G? Just because of the speed of information transmission? Of course, it's a very important aspect of this technology, but in reality, what makes 5G a necessary technology in the near future is, first of all, the possibility to enable a very high density of connections per unit area. And we are talking about something like 100 devices per square meter, or if you want, 1 million of devices per square kilometer. And this is a very important aspect if you consider that the fact that the number of connected devices tends nowadays to grow up exponentially. And making the exception for this aspect, there is another important aspect of this technology. The other aspect to consider is the very high availability of the service. When we talk about 99.999% availability, it means that we are talking about something like 5 minutes or less of downtime in a whole year. And if we think about mission-critical applications that require high quality of service, for example, vehicle-to-X communications, this specification for sure make 5G technology a necessary condition in that sense. So basically, 5G is able to provide improved performances. If we think about Internet of Things and critical communication use cases in general, something that basically LTE is not able to provide. So this is the added value of this technology. So new verticals applications will be realized that would have been unthinkable until now, and this could be even a new opportunity for the operators and service providers to grow up in that sense and develop their own business. And basically, let me say that the concept of the connection that turns into a service platform will overcome in that sense, because the connectivity will be more stable, widespread, and limitless for people and objects. So there is no difference between people and objects. Everything will be able to communicate with each other, and everything will be connected. So nowadays, several trials have been completed around the world, led by the major technology vendors and the international players such as Ericsson, Qualcomm, Huawei, and so on. Other trials are still in the planning phase, and basically through these trials, it has been possible to demonstrate the whole validity of different use cases, especially in the field of remote control, autonomous driving, and entertainment in general. And even if the world's first commercial 5G services have been already launched by some of the major mobile operators in collaboration with technological partners. For the instance, let's think about Qatar, which with the collaboration through the collaboration with ZTE has launched the first commercial service based on the 5G technology. Of course, with several limitations, since we have to attend the finalization of the release 16 by the end of this year in order to be able to see the whole potential of this technology applied to all verticals discussed before, with new with some new enabled services such as network slicing or differentiated quality of service, informing, etc., etc. So we have to wait the end of this year in order to be able to see the full potential of this technology. Just because some specifications should be defined before the end of this year. Okay, so let's now focus on the port community, and let's try to take a look on how this technology could enable or could provide some added values to the current intra-terminal operations, and how this is possible. So we have said before that the 5G has different industrial applications field that we call basically verticals, and for each area that is mapped in blue, it's possible to map a specific process related to the intra-terminal operations. Of course, this is a limited list of processes, but keep in mind that you are able to map your own processes within the specific application field. So we will have a process, for example, cargo management, that could fall into different areas. So the terminal cycle, in general terminal, I'm saying terminal cycle. So cargo management is the specific subtask of the terminal cycle. The terminal cycle can be seen both from point of view of automation, logistic, and cybersecurity, for example. So the application of 5G technology in this context could provide benefits in terms of improved automation, in terms of improved logistics, and in terms of cybersecurity. If we talking about cycle terminal, more specifically the cargo management. And this figure represents a schematization of how a specific process could benefit from the application of 5G. For example, you can see the verified gross mass management. You know that the transmission of this sensitive data can be done by ensuring a high level of data integrity through the 5G technology. Exploiting the low latency of the network, for example, we will be able to perform the data transmission in real time, reducing, for example, waiting times at the gates for the trucks, since this is very important information in order to be able to load or unload a specific container from a truck. Or let's talk about the controlled corridors. It is possible to enable a tracking service of the cargo in itself in real time along the entire logistic chain, simply using a 5G network distributed along the corridor. In this sense, it will be possible to enable, for example, some comparative and intelligent transport system services, for example, platooning or warnings related to any kind of situation, and so on along the corridor between the terminal and the destination point. Another application field could be represented by the ship practices management. We're talking about the real-time monitoring services of some critical parameters of the ships, for example, fuel consumption and so on. And now we are able to provide and share this information across the whole network. We are able to communicate with the port communities or with some facilities of the port community with the ship while the ship is still in sea. Or, for example, we could talk about docking assistance services for the ships through the application of remote control or autonomous driving, if we want to talk about connected vessels and autonomous vessels or platooning related vessels. Another field is represented by the cargo management, with the application of augmented reality, virtual reality, and assisted positioning services that are enabled by 5G technology in itself. And this is what we are trying to achieve within the COREALIS project. Just to complete this list, it's a basic list of processes that could benefit from the deployment of the 5G. There is another application field that is represented by the warehouse management. It's a specific process within the intra-terminal operations. And it would be possible, for example, to apply the remote control of the machinery in the warehouses to load the goods in the container before the shipment. So this is, how to say, a general overview, but with some specific application fields related to the intra-terminal operations. So, of course, we have to wait the finalization of the final release of this standard in order to be able to make an efficient use of this technology, just because currently some features are not available. Yeah, we could talk about the high data rates, throughput, bandwidth, but 5G is not only about all these aspects. There are several other aspects that should be taken into the consideration and that will represent the added value of this technology if applied to the intra-terminal operations or on a higher level within the port communities in itself. So that's all from my side.
Thank you very much, Alexander, for the presentation. I will now make a presenter, Ms. Elena Krikigianni, in order to be able to show us the social media of the project before we proceed to the QA session. Okay, Elena, would you like to share?
Hello, John. I think that my screen is already shared. Can you see my screen?
Not yet. Yes, I can see it. Sorry, probably my connection.
Thank you, Okay, social media are visible on the top right of the screen, and please now proceed with the quality assurance session and the questions and answers. I think that we have already one.
Yes, we already have one in our chat from Mr. Mauro Burati. So it's directed to Jarno and Alexander. 5G needs a license, so do you see this as a blocking issue for its usage in the ports? So would you like to give us our insight on this issue?
Okay.
Sorry, John.
Yeah.
Sorry for interrupting.
No worries, no worries. I can start. So this is a good question and a big, let's say, a problem between the visions and the realization of the potential of the technology. The scarcity of the spectrum from the technological point of view is tackled in 5G in a couple of different ways. For example, in addition to the licensed frequencies, there are a lot of work done to better introduce 5G networks to unlicensed bands, for example, in the 5 gigahertz and 6 gigahertz regions or spectrum. So there is a possibility to operate 5G networks also on unlicensed spectrum in areas that are not possible to utilize, or if there's for example not the commercial operators do not yet offer this kind of services on the licensed spectrum. And the other way to get the more coverage for the 5G network is the integration of satellite access in 5G. So satellite as an option, for example, for backhauling or greater coverage for the
5G networks is included in the standardization. So, for example, you could, in order to track containers or goods in containers in real time, also when they are shipped, or the ships are not in the ports but in transit in seas, you could use satellite backhauling to get the information from the ship to the systems inland. So there are technological possibilities and considerations in the standardization already for this, but of course the availability of the spectrum always depends on the regulation. So there's this regulation aspect that also needs to be taken into consideration, and it progresses separately from the standardization. But a lot of discussions are ongoing between the standardization organizations and the regulation bodies in order to get the technological and the regulation in line with each other, so that the spectrum for different use cases would be available as widely as possible.
Thank you, Jarno. I would like to overstep a little bit my role as a moderator here, because I'm also a telecom engineer who has been working for 10 years in the Piraeus port, and I would like to add that the most common business model that ports are actually evaluating for the application of 5G in their premises is via network slicing, that it is a technology supported by 5G, so that the license for the use of the 5G is supposed to be acquired by a telecom operator for their actual business, and a slice of this frequency, or a slice of their network, actually is going to be allocated for the use of the ports of the terminal operations. So that's the most common business model that is being evaluated for the 5G technology. Alexander, is there something else that you would like to add?
No, John, it's fine for me. The only thing that I could say is that currently, since the release 15 has been released, basically the current 5G solutions are commonly overlapped with 4G technology. So the first application of the 5G technology is based on non-standalone solutions. So just in order to answer to the question provided before. So yeah, the people will be able to apply the new technology using 4G in overlapping configuration with 5G. This is the first step. Then we will move within standalone solutions.
Thank you very much, Alexander. Are there any other questions from our audience?
Yeah, I see. It's Jarno here. I see additional questions in the chat.
Yes.
Chat window.
So we have one more question. It's, while 5G technology is moving forwards for countries or cities that do not switch as yet to 5G, what will be the implications for not putting the technology, as they don't see the need for it yet, and because many countries have invested heavily in 4G and 4.5G? Will they be able to apply the new technology development using 4G besides the benefits of 5G? Can 5G be implemented and out in places where it's truly necessary, such as port areas? So I guess it's for you, Jarno, and Alexandra as well. Would you like to take the step to answer it?
Yeah, of course, let's say the deployment of 5G networks in different areas are dependent on the operators and their business. Is there, for example, enough business potential or customers for the new 5G functionalities in the area so that the investment is meaningful. That's always a question for the operator, but we need to also remember that in parallel with the new 5G technologies, 4G is also continuously developed, and some of the let's say salient features of 5G are also making their way already in the 4G network. So a lot of things are possible also with the existing networks in the future as they evolve. So that's always a possibility. And again, from the regulation point of view, this kind of let's say dedicated implementations of 5G networks for areas such as ports, they are always possible, and there could be when the technology is a little bit more mature and available for or better available, these kind of third parties providing this kind of local deployments, for example, in the unlicensed spectrum. I'm sure that they will appear. So migration paths from 4G to 5G by the commercial operator is one way to get the connectivity, but there's also another possibilities in the future from third parties or other players, as the technology itself is more flexible and lightweight to implement.
Thank you, Jarno. Alexander, do you wish to add anything?
No, nothing. In the reality, the previous answer was related to the second question. Since I'm behind the small screen and I'm not able to see the whole questions. So my previous answer was related to this question.
Yes, I understood that, so that's fine then.
Sorry for this.
Are there any other questions coming from our audience? Okay, if there are no more questions, I would like to invite Ms. Elena Karagianni to perform the closing of our webinar and give us whatever information she wants about our social media.
Hello, everyone. I would like, on behalf of COREALIS Consortium, to thank you all for attending, and of course, thank the presenters for this webinar. It has been a great pleasure for us to share our work with you and have your feedback, of course. It goes without saying that today only a part of our work within COREALIS has been presented. More are coming in the near future. We always remain at your disposal for any inquiries you may have, so please feel free to contact us via any means of communication. You can see our social media on the top right on your screen, and please contact us and stay in touch with us. Thank you all.
Thank you very much for attending the meeting.
Okay, thank you.
Thank you. Bye.
Thank you. Bye-bye.